Welcome to Brain Vision.
In this question, this guy is sliding down a toboggan that makes 8 degrees with the ground. Acting on that guy, there are 3 forces: the weight force, the normal force, and the frictional force. Given that, how can you calculate what is the kinetic coefficient of friction in this situation? For that, we have to use Newton's second law in a special reference frame, which is this one. This will be what I will call the y direction, and this will be what I will call the x direction. Then applying Newton's second law on the y direction results in the following. So the net force on that direction is equal to the mass of the guy times the acceleration of the guy in this direction. Note that he's not flying away nor going below the toboggan. So the acceleration in this direction is equal to 0. Then the net force on the y direction is equal to 0. But the net force in that direction is composed by 2 forces. One is the normal force, which is pointing to the positive direction of the y-axis, and the other one is the y component of the weight force, which is this one. So this is the y component of the weight force, and it's pointing the negative direction of the y-axis, so n minus wy is equals to 0. Finally, the normal force is equals to the y component of the weight force. Okay, now applying the same equation, so applying Newton's second law to the x-axis results in the following. The net force on that axis is equals to the mass of the guy times his acceleration in this direction. He is sliding with a constant velocity, so the acceleration in this direction is equals to 0. Then, the net force in the x direction is equals to 0. But the net force in the x direction is composed by 2 forces: the frictional force, which points to the negative direction of the x-axis, and the x component of the weight force, which points to the positive direction of the x-axis. So this is Wx. Then, Wx minus the frictional force is equals to 0. Therefore, the frictional force is equals to Wx. But now, what do we do with that? Remember that the frictional force is given by the kinetic frictional coefficient times the normal force. So, the kinetic frictional coefficient times the normal force is equals to Wx. But we want to calculate what is the frictional coefficient. And the frictional coefficient can be given by the x component of the weight force divided by the normal force. But as we had seen before, the normal force is equals to the y component of the weight force. Then, mu k is equals to Wx divided by Wy. Then we have to use this rectangle triangle here to finish solving this question. This triangle looks like this. So we have here the hypotenuse, one of the sides, and the other side. And this is a 90-degree angle. Then this is the full weight force, this is Wx, and this is Wy. Now, what is this angle and this angle? So we can use this other rectangle triangle here to solve it. In this triangle, this is the 90-degree angle. Therefore, this other angle has 82 degrees, meaning that this angle inside the triangle must have 8 degrees. So this is an 8-degree angle, and this other one is an 88-degree angle. Now, what do we do with that? Well, note that the tangent of this 8-degree angle is given by the opposite side of the triangle, Wx, divided by the adjacent side of the triangle, Wy. Then, the kinetic frictional coefficient is given by the tangent of this 8-degree angle. And this results in a frictional coefficient of approximately 0.141. And this is the answer to this question.